What's up? I'm Vin, and I'm going to show how to graph one full cycle of sine or cosine. So these are the two equations that we're going to need, and let's get started. So first, we're going to graph one full cycle of y equals 4 times sine of 2x plus 1. And we'll identify the amplitude first. That's the coefficient of sine. So our a value here is equal to 4. And then next, we can look for the frequency. The b value is the coefficient of x, and here we have a b value equal to 2. And then next, we can look for the horizontal shift. The value c here is actually equal to 0 since nothing is being subtracted inside the sine function. If instead we had something like 2 times x minus pi over 2, then we could say the horizontal shift is pi over 2, but there's nothing being subtracted on the inside, so our horizontal shift is 0, which means we're going to be starting our sine curve on the y-axis. And then last, we could look for the midline. The value d here is equal to 1. And this tells us the horizontal line that's cutting through the curve. So what I imagine for all of these components here, so I just imagine a sine curve, and I'm just seeing we have a complete sine curve like this. The midline is the piece that's cutting through horizontally like this. And then the value a is the amplitude. That's the distance from the midline to the max, or we could say the distance from the midline to the minimum. The frequency is how many cycles the graph completes over an interval of 2 pi. And then the horizontal shift would just be where this graph begins on the x-axis. So when we want to sketch our complete cycle, are we sliding it to the right or the left? That's what the horizontal shift will tell us. So using this information, we could get started with the graph. So first, I'll transfer the midline over to the graph. So we have a midline at 1, and that's going to be a horizontal line, y equals 1, cutting through like this. So this is our midline. And then the midline helps you identify the maximum and minimum values. So what I do is I take the midline and I add the amplitude to it. So 4 plus 1 is going to give us a maximum value of 5. And then for the minimum value, so I'll just continue that thought over here. For the minimum value, it's going to be the midline 1 and then minus the amplitude. So 1 minus 4 is negative 3. And we could even see if we plot these values here or just mark them on the y-axis, we have a midline at 1. And then if I go up 4 units, so I'm going up 2, 3, 4, 5, this is going to be the maximum. And if I go down 4 units, so I'm going down 1, 2, 3, 4, then I'm going to be at negative 3, which is going to be the minimum value of my sine curve. So then next, what I like to do, once I use or identify the midline and amplitude to find the max and min, next I like to use the frequency to find the period. So just know that whatever the frequency is, so here, this is our frequency over here. We have a frequency equal to 2. We could say that the frequency is equal to 2 pi divided by the period. And then we could swap these two and say that the period is equal to 2 pi divided by the frequency. So this is going to be very helpful because now we could say the period equals 2 pi divided by the frequency is 2. These terms cancel, and it tells us we have a period equal to pi, which tells us how far we have to travel in the x direction to complete one full cycle, which is very helpful because we're going to graph one full cycle. So then next, I like to divide the period by 4 to find our x-axis scale. So I'm going to call it delta x, and I'm going to take pi and divide it by 4. So this tells us what to count by in the x direction here so that we're graphing our sine curve as accurately as possible. Just know the reason why we're dividing it by 4 is because we want to think of this sine curve as having 4 sections. So it's this section over here would be first, going from the midline to the max. And then the section over here going from the maximum to the midline is the second section. And then the third would be the midline to the minimum. And then finally last would be the minimum back to the midline. Okay, so that's why we're dividing it by 4. And then the next thing to consider here is how we're going to set up our x-axis. So we have a delta x equal to pi over 4. We are beginning on the y-axis because our horizontal shift is 0. So now we could just start here. So let's say every 2 jumps is pi over 4. So I'm going to start over here at pi over 4. And then if I go 2 jumps, a nice way to think about this, so I'll put another thought bubble over here. So how I like to think about this is if I'm counting by, and I'll just draw that a little neater, but if I'm counting by pi over 4, I go, okay, 1 pi over 4, and then next would be 2 pi over 4, then 3 pi over 4, and then finally 4 pi over 4. And notice the last one here, 4 pi over 4 just cancels to pi, which matches the period. Okay, so I'm going to go here, 1, 2, 3, and then another one like this. So this would be 2 pi over 4 next, which reduces to pi over 2. And then next would be 3 pi over 4. And then finally last would be 4 pi over 4, which simplifies to pi. So this is telling us how to cut up the x-axis. So now we could just go ahead and follow this pattern from before. So for sine, we're going to plot midline max, midline minimum, midline. So what that means is we mark it over here. We're starting on the y-axis, but we're starting at the midline first. Okay, so I'm going to start at 1, and then I go to the maximum. See, we have midline, and then we go to the max. We go back to the midline, we go to the minimum, and then back to the midline. So I go midline, I go over to the pi over 4, I go up to the max. I go over to the next entry here at pi over 2, I go to the midline. I go to the next value here at 3 pi over 4 in the x, and I drop down to the minimum at -3. And then at pi, the end of the interval, I go back to the midline. And I'm only going to graph one full cycle here. So now I'll just connect everything. So we just have to connect this as nicely as possible with the wave, like this. And this would represent one full cycle of this particular sine curve. But now let's check our answers. So we're going to graph here y equals, and we have our original equation was 4 times sine of 2x. We close the parentheses and we write our +1. So we press graph and notice that we get a bunch of waves here. But what I'll do is I'll go over to the window and I'm going to restrict the domain to go from x minimum 0 up to x maximum pi. And for this part, just make sure that you're in radian mode to get a nice graph. And then next what I'll do is I'll make my y minimum -3 and my y maximum 5. And we press graph and notice we get one full cycle. Now I could also add in something like this. I could add in the line y equals 1, and that's going to throw in the midline. And if I just want to make sure my values are accurate, let's say I press second trace value. And let's say I want to test out pi over 4. That should bring me to my maximum at 5. So I do this, and notice that it brings me to my y value 5. It puts me at the top here. If I did second trace value and I typed in pi over 2 next, this should put me on the midline, and it does. It puts me at y equals 1. Okay, so this graph here is checking out. For this next example here, we're going to graph one full cycle of this cosine curve defined by this equation. So first I'll find the amplitude, and our amplitude is equal to 3. Okay, so that's the coefficient of cosine here. That's going to tell us our amplitude. And then next I'll find the frequency, which is the coefficient of x on the inside. So our frequency is also equal to 3. And this time around, we actually have a horizontal shift other than 0. So we have a horizontal shift here equal to pi over 4. And what this tells us, it tells us where to begin. Okay, so we're going to begin at pi over 4 on the x-axis. So we have our x-axis and our y-axis. And then at the end, we have our midline. And our midline here, we could say, is y equals -6. So before I use the equation, and I call this A, B, C, and D, but the midline is a horizontal line, so I could also just name it as y equals -6. So now I'll transfer some of this over to the graph. So we have a midline at y equals -6. So that's down 1, 2, 3, 4, 5, 6. So that's over here. So I'm just going to draw a dotted line like this going across. And this represents the midline of our cosine curve. And I'll just label over here on the number line here, or along the y-axis, we'll call this value over here is at -6. And then the next thing to think about is the amplitude. So we combine the midline and the amplitude to find the maximum and minimum. So since the amplitude is 3, I'm going to go up 3. So I'm going up 1, 2, 3 like this. And this tells us our maximum value is -3. If I go down 3, this tells us our minimum value is at -9. So this is going to be the max height of the curve and the lowest point of the curve. And then from here, we could use the frequency to find the period. So remember, the period is equal to 2 pi divided by the frequency, which is 3. And what this will tell us next, if we divide the period by 4, this tells us what to count by. So we're going to go 2 pi over 3 divided by 4. And if I want to divide by 4, I could also just multiply by 1/4. So 2 over 4, let me just simplify this. 2 over 4 reduces to a half. And then I get pi times 1 is pi, over 3 times 2 is 6. So we're going to be counting by pi over 6s. But what makes this example a little bit trickier is we also have to account for this horizontal shift. So we're going to be beginning at pi over 4, but I'm going to think common denominators here. So I'm just make that a little neater. So the concept here of common denominators helps us to see what to scale our x-axis by. So we have a horizontal shift of pi over 4, and we're going to be counting by pi over 6s. So here we should find common denominators. I'm going to multiply the top and bottom by 3 to get 3 pi over 12. And then here I multiply by 2 over 2 and I get 2 pi over 12. So what this tells us is we should count by pi over 12s along the x-axis. We are beginning here, okay? So when we actually sketch out the cosine curve, the horizontal shift tells us where to start our one full cycle. So we're going to begin at 3 pi over 12. So I'm going 1, 2, and then 3 pi over 12 would be here. And then from this point on, I'm going to be counting by 2 pi over 12s. So let me just make this a bit smaller from when we actually label the x-axis. So I'm going to just drop this down a bit. So here we are beginning at 3 pi over 12. But just know 3 pi over 12, I could reduce this down to pi over 4. Okay, so we're going to begin here at pi over 4. And then when I go forward here, another thing that I'm thinking about, so I'll just put this idea over here up top, is if we are beginning at pi over 4, which is the same thing as 3 pi over 12, and we are counting by 2 pi over 12, I just add 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. And then I go another plus 2 pi over 12 gives me 7 pi over 12. And then 9 pi over 12. And then finally 11 pi over 12. Okay, so that's what I'm imagining here going along the x-axis. So pi over 4 is the same thing as 3 pi over 12. The next one here I could just write exactly as is, as 5 pi over 12 because it's reduced. And then if I go forward again, 7 pi over 12 is simplified already. So 7 pi over 12 I could just write. But now this entry here, if I want to be extra precise, I could reduce 9 pi over 12 by dividing the top and bottom by 3, and I get 3 pi over 4. And then finally, for the last value here, if I go plus another 2 pi over 12, I get to 11 pi over 12. So this would tell me the end of the interval here for our full cycle. So now I'll bring this back up, and we'll just go ahead and plot these points. So for the cosine curve, just know that the theme here is max, midline, minimum, midline, max. So when we're graphing one full cycle of a cosine curve, so what I'm imagining over here is that we have a curve that looks like this, and the midline is going to be cutting through horizontally like this. But this time around, we are going, once again, we're going max, then we go to the midline, we go to the minimum, back to the midline, and then to the max like this. Okay, so at pi over 4, that's where we're beginning here. Horizontal shift at up of pi over 4. Don't begin on the y-axis, you begin at the horizontal shift. So we're going to begin here at the maximum, and then at the next entry, we go to the midline. The next entry, we go to the minimum down here, and then next we go back to the midline, and then finally for the last entry at 11 pi over 12, we're back to the maximum. And then next what we'll do is we'll just connect these here with the cosine curve. So we're going to go down like this, and we're going to swing it this way like this, come back up, and then we will complete our cosine curve. So now let's go to the y equals and check our answers. So we're going to type in, we have 3 cosine, and then we have 3 parentheses, x minus pi over 4. So I could just write pi divided by 4, or I could press alpha y equals enter and pull up a blank fraction and write second, the up arrow here, and we have over 4. And then I close the parentheses around x minus pi over 4, and then I close it again around the whole inside here. And then we have minus 6 on the outside. And the midline is occurring here at y equals -6 this time. So if I press zoom 6 and put the graph back to normal, we could see our cosine curve like all the way here from -10 to 10. But I will go to window and I will make my x minimum at pi over 4 and my x maximum at 11 pi over 12. And if we did this right, it should give us one full cycle. And for the lowest point, I'm going to go down to -9. And for the highest point, we're going up to -3. So let's see if we get one full cycle. And we do. And if I just want to check some of these values here, I could do second trace value and type in 11 pi over 12. And so I'm going to put in the last value here, and it should put me up to the max here. And it does, all the way at the end of the graph. If I want to check this value here at 5 pi over 12, let's see, second trace value, 5 pi over 12. And this is just a nice way to check our answer. Notice that it throws us right on the midline, as it should. So our graph checks out. For the last question, we're going to graph one full cycle of this sine curve defined by this equation here. So first we'll identify the amplitude. So we have an amplitude here equal to 5. And I know that there's a negative in front, but the negative, the way that's going to affect the graph is it's just going to make the sine curve go upside down. So when we graph our full cycle here, it's going to look, instead of going up like this and down, it's going to go down and then up like this. Okay, so that's what our that's what our finished product is going to look like. And we're going to have our midline here. And then the rules are broken from the steps I had written before. Now that everything's flipped, it's going to go midline to the minimum. So we're going to have midline, and we'll just color code this here. So we're going to have starting at the midline, we go to the minimum, back to the midline, to the max, and then back to the midline like this. Okay, so that's how our graph is going to look at the end. But we got to find each component to know exactly where to place it. So then next we have a frequency equal to +2. This time around, we could say that we have a horizontal shift. And if we look for our horizontal shift is equal to pi. No, this is a very dangerous bear trap. You just have to make sure for these questions that when you look for the horizontal shift, the inside, the argument of the sine or cosine function should be factored. So we should say that this is equal to -5 times sine, and I'll throw in a bracket here. This is 2 times parentheses x minus, and if I divide each of these pieces by 2, for the first one I get x, and the second piece, if I do pi divided by 2, I get pi over 2. Okay, so our horizontal shift is actually pi over 2. And then I write my +2 on the outside. So just be careful there, because that is a very common mistake, is students forget to factor this. So the horizontal shift here is equal to pi over 2. And then our midline, we could say that our midline is going to be at y equals 2. Okay, so these values are going to be very important. So I'm just going to start off the graph here. So we have a midline at y equals 2. And we're going to use the midline and the amplitude to find the maximum and minimum. So I'll label the x and y axis as well. And now for the maximum, we have a midline of 2, and our amplitude is equal to 5. So I go up 5, I'm going up 1, 2, 3, 4, 5, and that's going to put me at a y value of 7, because I go 3, 4, 5, 6, 7. I could just also say 2 plus 5 is 7, and then I could say 2 minus 5 is -3, telling me that the minimum is going to be down here, or I could just count the boxes down 5. So now that we have this, let's just think here. The value here, pi over 2, represents where we are going to begin on the x-axis. Okay, the horizontal shift tells you where to begin. And we could also say here delta x, or first let me find the period. The period is equal to 2 pi divided by the frequency, which is just equal to pi. So then delta x is the period divided by 4. So pi over 4. And this is just telling us what to count by. So now I just have to think very carefully here. So how do I start this? So don't rush your way through these questions. It's very easy to miss one small detail. So I'm just very, very careful with this part here. So the horizontal shift is pi over 2. But just know pi over 2, I could also call 2 pi over 4. So just multiply the top and bottom by 2. The reason I do this is because now my delta x is easy to, add to this value here. I need common denominators if I'm going to add this delta x value. So now I could skip forward by pi over 4s. So my next value would be 3 pi over 4 if I do plus pi over 4. And then 4 pi over 4. And then we would have 5 pi over 4. And if I have to go one more, it would be 6 pi over 4. Okay, so these are the values that we're going to throw on the x-axis. So here it makes sense to count by pi over 4s. But what I'll say is every 2 jumps, I'll call pi over 4. So this would be 1 pi over 4, and then I go 2 jumps, that would be 2 pi over 4. And this I'll reduce down by dividing top and bottom by 2. I'll reduce this down to pi over 2. And let me just adjust the font size here so that it shows up nicely on the x-axis. So we're going to say here that this is pi over 2. And then we go forward 2, and we're going to say each 2 jumps is going to be jumping pi over 4. So the next would be 3 pi over 4, which is reduced as far as possible. And then after this, we would be at 4 pi over 4, which reduces to pi. And then after this, we'd have 5 pi over 4. And then finally, last, we have 6 pi over 4, but that we could reduce to 3 pi over 2 when we divide the top and bottom by 2. So these are the values we're going to use here to draw our graph. So now I'll just switch this back, and we'll go ahead and get started. So here, remember, everything is flipped now because we have a negative in front of our sine curve. So when we plot this, we're starting on the midline first. So we go to pi over 2. That's where we're going to begin, at pi over 2. And we go midline to the minimum. And the minimum is down here at -3. So at the next entry here at 3 pi over 4, we're going down to the minimum. And then at pi, we go back to the midline. 5 pi over 4, we're going to the max. And then finally at 3 pi over 2, we go back to the midline. And then all we have to do now is just connect this with our sine curve like this. So we're going down and then up. And then I do the same thing here. I go up Or I just do the flip here. I go up and then down, and there's our full cycle of this sine curve. So let's just type this in. We have -5 times sine of 2x minus pi, and we close the parentheses, and then we tack on +2. And then for our midline, we have a midline at y equals 2. So I'm going to do this. I'll press zoom 6 to put the graph back to normal. And there's our curve. So what we want to do, though, is see if our full cycle shows up where it's supposed to. So we're going to go over to the window, and we're going to make the x minimum pi over 2. We'll make the x maximum 3 pi over 2. And then after this, we'll make our y minimum -3 and our y maximum 7. And we press graph, and there is our full cycle. If I just want to test some value, second trace value, and let's say I test this value here at pi. So I press second and the up arrow here to get pi, and it puts us exactly at y equals 2. Okay, so this one is checking out. If I type in 5 pi over 4, it should put me at the maximum value here. So second trace value, and then I write 5 pi over 4, and this puts us at the maximum value here at 7. So our graph checks out.